Okay, the question becomes, how do we get to such big numbers when we have thousands, hundreds of thousands, millions, billions, trillions? How do we get to such big numbers? So what I wanted to do is show you how things grow. And a lot of times things grow what's called exponentially. We can have linear growth, which would be like each week we add 5 new cases of COVID. But that's not what we have. What we have is exponential growth. Day 1, it's 1 person, then it's 2 people, and then it's 4 people, and then it's 8 people, and then it's 16 people, and it starts doubling every single time. And this is a very realistic growth model. Think about it. 1 person goes into class that's sick all day, right? What's the chances? Well, they get at least probably 2 other people sick. Well, then those 2 people the next day go into class, and then each of them gets 2 people sick. And that's called exponential growth when that starts happening. So this is a very serious thing. In fact, it shut our nation down. It shut the world down on a world stage is because of exponential growth and how things grow mathematically. So that's what I finished this packet off with was, let's model this exponential growth to see what happens. Now, we're not going to do it in such a realistic way. We're not going to sit here and look at the actual growth models of COVID. What we're going to do is something ridiculous and more fun. We're going to catch ourselves a leprechaun. So let's take a look at this. It says, you can catch a lucky leprechaun with a magic penny. This penny doubles in value each day. For instance, day 1, you would have 1 cent. Day 2, you would have 2 cents. Day 3, you would have then 4 cents, and so on. It says complete the following chart. So here's where we're at. First day, you have your penny. Overnight, it doubles, so it becomes 2 cents. Overnight, that doubles, so now you have 4. And day 4, and we're looking at the total value here. So day 4 would be what, 8 cents? Day 5 would be 16 cents. Day 6 would then be double, that's 32 cents. And day 7 would be what, 64 cents is what we'd have. Okay. So there's the amount of money we have. We're sitting after, it's our 7th day, and on our 7th day, we have 64 cents in our pocket or in our safe or wherever we have it. So I'm going to give you an option. It says the leprechaun gives you an offer. He will give you either $1 million cash in hand now. Remember, you have 64 cents and you've been there for a week. Or he will let you keep the penny for 1 month. So you've already had it for 7 days, and he'll let you keep it for a total of 31 days. So on that 31st day, you have to give it up. Which one do you choose and why? So, I ask my students this in class, and I have them choose, and I have them raise their hand, and then I have them debate. And I don't want you to do the math yet, I want you to think. And most people sit there and say, okay, we just got done learning that $1 million's a lot, right? 64 cents is nothing. So after a week, I have 64 cents. I'm done. I'm not taking it. I'm going to take that $1 million cash. And I say, okay, sweet. But I need you to justify mathematically why your choice was the best choice. So we look at this. And I want you to start doing the math. So choice 1 is $1 million. Okay. Let's look at choice 2. How would we determine how much money we would have with choice 2? Well, am I going to sit there and just going to do, so I have 64 cents, right? Do I do times 2, and then times 2, and then times 2, and times 2? And I end up doing that, well, it doubles 30 times. In 31 days, it has doubled 30 times, right? Or is there an easier way to figure it out? And so this is where we want to try inspecting something a little different. What I want you to do is I want you to think about the number of pennies. Okay, so instead of the amount of dollars, I want you to think of the number of pennies. So this starts off with 1 penny, then it would be 2 pennies, and then it's 4, and then 8, and then 16, then 32, and then 64, right? That's the number of pennies. And I want you to try to find a model from the days, let me highlight that, from the days to the number of pennies. Is there any way that you can relate those two things? So 1 and 1, 2 and 2, 3 and 4, 4 and 8. What's happening there? Well, if you look at the model here, how many times, each time it doubles, you multiply times 2, right? And just as a quick reminder, if you multiply things by 2 a lot, you'd have 2, like for instance, if I multiply it times 2 3 times, that's 2 to the third. That's exponential notation, right? So the question is, how many times have we doubled? Well, notice when we look at the first one, we've doubled 0 times. So it's 2 to the 0, and anything raised to the 0 is 1. You can put that in your calculator. 2 would be 2 to the first. 4 would be 2 squared. 8 would be 2 cubed. We've doubled 3 times. 16 we've doubled 4 times. And hopefully you're starting to see a little pattern. 32 is 2 to the 5th. 64 is 2 to the 6th. I want you to look at that exponent in the day number. So it looks like the numbers of pennies is 2 to the day number minus 1, right? That's how many pennies we are. Now to get the dollar amount, all we have to do is say how much a penny is worth. Well, a penny is worth 1 cent, $0.01. So how do I know how much I have on any given day? It's 0.01 times 2 to the day number minus 1. Well, what day do we have to give it back? We have to give this back on day 31. So how much would we have? We'd have 0.01 times 2 raised to the 30th power. Again, 30 because we've had it for 31 days, but we've only had it for 30 nights, and it doubles at night. So it's not 2 to the 31st, it's 2 to the 30th. So do in your calculator 0.01 times 2 raised to the 30th power, and hit enter, and let's see what you get. I'm getting a total of 10737,418.24. So how much money would you have? Be over $10 million. So which one do you want to choose? Choose the penny for sure. It's insane. I encourage you, if you're in anything decent at Google Sheets or Microsoft Excel, get on there and just do this. It's really easy because all you have to say is equal, click on the previous cell, and do times 2, hit enter, and then you drag and drop. If you know anything about Excel, you know what I'm talking about. And it'll just copy it. And I want you to see how quick that money grows. So after 7 days, we only have 64 cents. But if we keep on doubling, after 1 month, we're at almost $11 million. Absolutely insane here, right? That is why we were worried about COVID. That is why we were worried about exponential growth. It wasn't quite doubling. The amount doubling, it wasn't quite doubling every single day, but it was a factor of about 1.6. So instead of doing 2 to the power of, it was like 1.6 to the power of. So what this would be saying is roughly after 31 days, after 1 month, we don't have $10 million. We have over 10 million people sick. Notice what happens in just 1 more day. How long? If it took me 31 days to make $10 million, how many days does it take to make $20 million? And the answer is just 1 more day. It takes 32 days to make $20 million. How do I know that? Because what happens every single day, it doubles. So think about that happening in our population. Had we not been quarantined, had we just gone to our daily lives, that factor, that 1.6-ish, whatever it was, that growth factor that COVID was growing at, would have stayed the same if not gotten bigger. It wouldn't have been 100,000 people dead. It would have been millions of people dead. We had to stop that exponential growth, and that's why they put us in quarantine. Exponential growth gets out of control very quick. So we know our national debt. We know our national debt's absolutely insane, right? We just looked at it, and it's about $25 trillion. So again, I encourage you here. You can play around on your calculator, but the idea is what we're doing is 0.01 times 2 raised to the, figure out what number is approximately 25 trillion. So we want that number to be greater than or equal to $25 trillion, trillion being 12 zeros. So what do I need that exponent to be? Well, you could play around on Excel here. Just continue down and look to see when your total amount would be. But I'm just going to play around in my calculator a little bit. I'm going to put in a random power. And what I'm seeing when I put these numbers in, large numbers in, for instance, I just put in the number 50 as a total guess. And when I put in the number 50, so I did 0.01 times 2 to the 50th power, and I hit enter, what I'm seeing is a 1.1 times 10 to the 13th. So what does that mean when I see something like 1.1 times 10 to the 13? It says 10 to the 13th. What does that mean? Well, that means move that decimal to the right 13 times. That means I have 13 zeros after that 1 is what that means. So look at what that would be. That would be 1, 0, 0, 0, 0, 0, 0, or sorry, not, that would be 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So 10 to the 13th, 1 times 10 to the 13th would be $10 trillion. So that's not enough. So what happens if I do to the 51st power? Well, give it a try. I'm getting 2.25, so that'd be 22 trillion. That's enough. Not enough. So let's go ahead and try to the 52nd power. And for the 52nd power, I'm getting enough. So what I'm seeing is that 0.01 times 2 to the 52nd power is greater than 25 trillion. In fact, it's about 45 trillion. So that means the day minus 1, I need it for 52 nights. And that tells me I need the penny for 53 days. So how many days do I need that penny for? I need that penny for 53 days. Okay. Like stacking the dollar bills. That's not long, by the way. 53 days you'd be able to pay off the national debt. My answer to that is instead of spending $5 billion on a border wall, why don't we spend $5 billion to find this damn leprechaun, right? Just joking. But it would be really, really nice to find this magic penny, right? Have it for one more day than that, and we could retire happy. All right, so as it says, if you stack the pennies on top of one another, which remember, we got to be careful with the number of pennies there are. If you stack the pennies on top of one another, how high would it reach after 45 days? Compare this to the distance of Mars. How many days would it take to reach Mars? Okay, so let's check this. We have it for 45 days, so we're looking at the number of pennies. Remember, the number of pennies is 2 to the day number minus 1. 2 to the day number minus 1. So for our number of pennies here, I would have it for 44 days, right? Okay. So how many pennies would be 2 to the 44th pennies? Okay, that's a lot of pennies. That's how many pennies I would have. So now what I need to do is I need to look at what's the size of a penny. So go ahead and look at the height of a penny, and again, we're just going to take a penny and then we're just going to stack them on top of each other, right? And the question becomes, how high does that stack of pennies go after 45 days? Now, I think I screwed up this problem, and that's perfectly fine. Let's just figure out the question as it asks. Go ahead and look at the height of a penny, so I want you to Google that. I'm getting approximately, very, very small, but 0.0, it says 0.0598. I'm going to go with 0.06 inches here. Okay, that's the height of one penny. And then we know this is going to be huge, so we're going to say there's 12 inches to 1 foot. And then again, we're going to say there's 5280 feet to 1 mile. Inches cancel, pennies cancel, inches cancel, feet cancel, and this is going to tell me how many miles high is this going to go. So in my calculator, I'm doing the N over D button for a fraction. In the numerator, I'm going to put 2 raised to the 44th. Get out of the power, and I'm going to do times 0.06. In the denominator, I'm going to do 12 times 5280. I'm going to hit enter, and I'm getting a total of, well, let's write this down. Let's write this number down. It's approximately, and remember this is an estimation, 1665927.09. That's about 16, 17 million miles. Okay. Pretty dang far here. So how far does this go? Well, go ahead and Google the distance to Mars. So I'll do shortest distance between Earth and Mars in miles. And let's see what we get. And I'm getting about 33.9 million miles. Is the shortest distance that we would have. So what I did wrong when I wrote this problem is I said for 45 days, and what I really meant was 45 nights. Because if I did this for 45 nights, we would take that number and double it. That would give us roughly 32, 33 million, and it would be almost exactly the distance to Mars. So if I had this penny for 45 nights, we could stack the pennies up and we could just climb it to Mars instead of going on Elon Musk's SpaceX journey that just launched a couple days ago. Okay, pretty cool. Let's continue on with some more.